Hi guys, this is Shubham. Welcome you all in your channel. In this video, we will deal some basic questions of IIT JEE mains which is related to electric circuit on topic voltmeter and ammeter. So let's get started. At time t is equal to 0, which one of the following statement is correct? Circuit diagram is this. There are 4 options given in which one is correct. So let's solve this question. First of all, we redraw the circuit here. Make sure there is no connection between them. So in first case, we consider before switching. So before switching, current is flowing in this manner. Suppose say current I1 is flowing, so polarity because this is a positive terminal, that's why current is leaving from here and entering, it means plus, and leaving here negative. So apply KVL in this loop. We start from here, minus E1 plus I1R plus I1R2 minus E2 plus I1R equal to 0. So we can rearrange them. Take I1 common. So we get the value of I1 E1 plus E2 divided by R2 plus R1. So this is the value of I1 before switching. The question says switch as is closed at time t is equal to 0, means in second case we have to consider after switching, means the interesting thing happened here. Means these two terminals short circuited this battery, so that's why no current flow in this section. There is no current flow in this section, the current flowing in this manner. Let's say current I2 is flowing. So again apply KVL. Nomenclature is this one. So we start from same point, E1 plus I2R plus I2R1 equal to 0. So we get the value of I2 equal to E1 R plus R1. So after all, we get the value of I1 and I2. So let's check the option. The option says that current in the resistance R increases, decreases, and these are the conditions. So let's check condition. Means suppose after short circuiting, current I2 may be decrease or increase. So first of all, we take I2 increases, means I2 is greater than I1. So put the values of I2 or I1 here. E1 is greater than E1 plus E2 R plus R2 plus R1. So cross multiplication, R2 plus R1 is greater than E1 plus E2 R plus R1. E1 R1 multiplication inside, E1 R2 is E1 R1 greater than E1 R1 E2 R plus E2 R1. So this E1 R1, this E1 R1 same cancel out, and even R and even R same cancel out. So we get even R2 is greater than, take E2 common from here, R plus R1. So we get the condition here. In second case, we can say I2. In second case, we can say I1 is less than I2. What is the value of I1? Sorry, in second case we can say I2 is less than I1. So what is the value of I2? E1 upon R plus R1. E1 upon R plus R1 less than, value of I1 is E1 E2 divided by R plus R1 R2. So let's solve this equation. Inside multiply, let's check. Even R cancel out, even R1 cancel out. So we get even R2 less than E2 R plus R1. So we get two conditions from. Let's check the option. Even R2 is greater than E2 bracket में R plus R1. So this option is correct. Another option is even R2 is less than E2 R plus R1. So even R2 is less than E2 bracket में R plus R1. same. What the point is to be noted that this is the case for decreasing current in the resistor R, and this is the case for increasing current in resistor R. That's why this option is incorrect. Only one option is correct. Next question is, ABC are voltmeter of resistance this and this respectively. When some potential difference is applied between the terminal X and Y, the voltmeter readings are VA, BB, BC, then which condition is satisfied? So, to solve this kind of problem, first of all, we draw its circuit diagram. The meter A of its resistance R, ammeter B of its resistance 1.5 R, ammeter C of its resistance 3 R. As the question is saying, when some potential difference is applied between X and Y, suppose say E is applied. Now the current is flowing in this manner, let's say I. These two are in parallel combination, so 1.5 R into 3R divided by 1.5 R plus 3R, 4.5 R divided by 4.5, we get R. So the parallel combination of these two will get R. So the circuit converts in this manner, R, R. These are is in parallel combination of these two, X and Y. Now we have to find the potential difference across VA and across this parallel combination. So first of all, we need to determine current I. So I is equal to E divided by 2R. This is the current. So potential difference VA across R is equal to IR. Put the value of I from here. E divided by 2R cross R. So we get the value of VA equal to E by 2. Now we have to find voltage difference across parallel combination. The voltage difference across parallel combination equal to IR equal to E divided by 2R. Put the value of I here and R, cancel out E by 2 equal to V parallel. So the voltage difference across the parallel combination of these two remains same due to the parallel combination. So we get the value VA equal to VV equal to BC is equal to E by 2. So the option VA, VV, VC, these two is equal and other is only A option is correct. Three terminal A, B and C of resistance RA, RB, RC respectively are joined as shown. When some potential difference is applied across the terminal T1 and T2, the readings are IA, IV and IC respectively as shown in the figure. circuit diagram is this and the option like this. So let's check which one option is satisfied to this circuit. So as we know, ammeter A and B are in series, so the current is in series remains same. That's why we can say IA equal to IV because of series combination. So we have to find first of all potential difference across AV. IA current is flowing. IA, let's say resistance of ammeter RA, RV, RC. So IA RA plus IV RV. Potential difference across AV is equal to IA RA plus IV RV. Already known IA is equal to IV. So IA common RA plus RV. Potential difference across VC is IC RC. Ammeter A and B and C are in parallel combination. That's why potential difference across ammeter C is equal to the potential difference across AV ammeter. VAV equal to BC. IA RA plus RV equal to IC RC. So IA divided by IC equal to RC divided by RA plus RV. These are the conditions. Let's check the option. First, IA equal to IV. First option is correct. Another one is IA RA plus IV RV equal to IC RC. This option is also correct because the potential difference across AV equal to the potential difference across C. A and B is correct. C option, potential difference across A, IA RA is equal to IC RC. No, this option is incorrect because potential difference across whole A and B, not A. D option, IB divided by IC is equal to RC upon RA plus RB, means potential difference across A and B equal to the potential difference across C, means this option is also correct. IA is equal to IV. So put the value of here IV and get the answer D. 3 option is correct. 3 voltmeter, all having different resistance, are joined as shown in the figure. When some potential difference is applied across A and B terminal, the readings are V1, V2, V3. Then the option is this one. So let's solve this question. Let's say the resistance of V1 is R1, resistance of V2 R2, the resistance of V3 is R3. They clearly mention in question that having different resistance, so we can say R1 is not equal to R2 is not equal to R3. That's why potential drop across R1 is not equal to R2. So A option is incorrect. V1 is not equal to V2. V1 is not equal to V2. V option is correct. C option is saying V1 plus V2 equal to V3. Means some potential difference is applied across A and B. Let's say E or B potential difference is applied. Whatever potential is applied here, distribute here and here in the same or equal, because these two voltmeter and this voltmeter are in parallel combination. That's why voltage remains same here and here. So the sum of the potential difference across V1 V2 is equal to the V3. VR1 plus VR2 equal to VR3. What? This option is also correct. What the option D is saying, V1 plus V2 is greater than V3. V1 and V2 is greater than V3. It cannot possible because the circuit are in parallel. Parallel means the voltage across V3 is same or equal to the voltage across V1 and V2. V2 is not greater than V3. This option is correct. Next question is, in the given circuit, the current flowing through the resistance 20 ohm is 0.3 ampere, while the ammeter reads 0.8 ampere. What is the value of R? The circuit diagram is like this. The options are this. So now let's solve the question. The question is clearly saying that the current flowing through the resistance 20 ohm is 0.3 ampere. So 0.3 ampere flowing through 20 ohm resistor, and ammeter reads 0.8 ampere, means 0.8 ampere leaving from this side. And the one important fact is to be noted that here, and we have to understand the fact that whatever current leaving from here, exactly the same amount of current entering from this side. Path is not showing. What we have to understand the fact that whatever current leaving from here, entering the same amount of current from this side, 0.8 ampere. After this, out of 0.8 ampere, 0.3 ampere goes to 20 ohm, and remaining current goes to this side and this side as well. So we have to rearrange it. Firstly, we clearly see that 15 ohm and R1 are in parallel combination of each other. 15 R1 divided by 15 plus R1. .3 ampere flow from 20 ohm, and the remaining currents out of 0.8 ampere, 0.3 ampere flowing from the 20 ohm resistance, and the remaining current is 0.5 ampere flowing from parallel combinations of these two. Now the voltage developed across 20 ohm is V equal to I R to 6 volt is developed across 20 ohm. And the important point is that whatever voltage is developed here, same amount of voltage appear here because of parallel combination. So apply Ohm's law. V equal to IR, V 6 volt, I 0.5 ampere, R parallel combinations 15 R1 divided by 15 plus R1. Calculate it. 5 2s are 10, cross multiply, 12 equal to 15 R1 divided by 15 R1. Cross multiplication into the 180 plus 12R1 equal to 15R1. Rearrange it. 3R1 equal to 180, R1 equal to 60, 3 6 60, 60. So R1 D option is correct. C is wrong, B is wrong, A is wrong. If you have still any doubt about this question, please comment in the comment section. I will resolve that as much as possible. If you liked my video, please like, share and subscribe. Thanks for this watching.